So hello guys. So now I am live. Today is the day third of doing the machine learning AI interviews related question. So today is the day third, or today I am going to explain you the understanding of logistic regression. Previously, I have talked about the linear regression and like the roadmap that you have to follow to learn the machine learning. Today is the day third, and today I am going to explain you the logistic regression algorithm that you have to learn. So now coming to the point. So firstly, now we will see that after some times. Firstly, see this video, not video. See this text. Okay, so now we are starting to understand the logistic regression. So classification techniques are an essential part of machine learning and data mining applications. Approximately 70% of problems in data science are classification problems. So basically, they are saying that in the universe, that all algorithms that we have today now, like problems that we have to solve, maximum problems like 70% of the problems in the universe are of classification. So basically, the logistic regression is used for to solve the classification algorithms of problems. So logistic regression is one of the most simple and important machine learning algorithm, that first algorithm that you have to learn for the classification problem. And so what is logistic regression? Logistic is a statistical method to predicting binary classes. Yeah, so basically this algorithm used to predict the binary classes of a problem. If you have a binary classes, like binary means two classes. If we in your problem, if your problem you are solving will contain two classes, like a man has cancer or not, then you have to use this algorithm. Okay, so linear, this is given the linear equation formula you have already know, by equal to mx plus c. So here by is this and beta naught is the your c, we can say that. And these are the some what we say that, but this is the intercept and this is the exponent term that we have are in the equation. So what we have to do in logistic regression, is there any diagram? Okay, there is the diagram. So firstly we will see this. So we have already learned this. If you want to solve a logistic regression problem, then this is basically firstly a linear regression problem. Like suppose there is some point there, these and these points are there in the above, and by the y-axis you see that. So this will in other class, and this above point are in the another class, but are in the second class. So if you want to create a machine learning model that will say this in the zeroth class and this is will goes to in the another class. So you want a model that will say that if you apply a linear regression, then there is a problem. Like this will create only a linear equation. So if a point will come, suppose here, then this will say that okay, this will point coming to the below, then this will come to the this class. So what we the scientists have done, they apply a sigmoid function on top of the linear equation. So what the sigmoid will do, this will squeeze your function in such a manner that your value that suppose in linear regression your value was ranging from 1 to 1000. Then by applying a logistic regression, your value will normalize into a range of 0 to 1. So what this will do? Firstly, the computation will decreases, because now you have to predict only in the range of 0 to 1. So that's why this is important. And so Firstly, we have applied a linear regression, and then on top of the linear equation, we applied our sigmoid function. The sigmoid function is 1 upon 1 plus a raised to the power minus y. So here the is your linear function, and will come to minus by place. So this is the logistic regression equation that we have to follow. Or we can say this is a dependent variable and logistic regression followed by knowledge distribution. Essentially, all these are not good. Linear regression versus logistic regression. Here we have already seen that in linear regression, on top of the linear equation, we have to apply logistic regression to find the values. Maximum likelihood estimation versus least square method. Or we can say that MSC mean squared error, like sigmoid function. We have already see that this will basically convert your values into a 0 to 1 range, so that your model will work in a good way. With pros. Type of logistic regression. Binary logistic regression is there. Like if you have only two class to predict, then you can use a binary logistic regression. Multinomial regression, logistic regression is also there. If you have three or more than three number of categories, then you can use a multinomial. Ordinal logistic regression is also there. The target value has three or more ordinal categories such as restaurant or product rating from 1 to 5. Then you can use same as multinomial, but here you have like ordinal variables. Model building. Now coming to the model building, how to build a logistic regression model using a logistic in a scikit-learn libraries. So basically, firstly, now coming to this, the code is also given here. Import the pandas library, and this is the column names in your data set. You have already, like, I have already like data set that will contain prime Indian diabetes data set. I have, like, in this data set I have pregnant, glucose, BP, skin. These are the columns, and these are values are there. According to this value, we have to predict is a pencil have diabetes or not, and these are the labels already given. That we already see that in the previous video, like what is the difference between supervised and unsupervised. So basically, this problem is the supervised learning because we have a labeled data set. And logistic regression, we already know this will comes into the supervised machine learning algorithm, the category. Now selecting the features, that features basically these are the independent variable, and dependent variable is by is the target variable, or we can say that the dependent variable, and these are the independent variables x. Now from sklearn model train test split, we have done like training and testing, and after training testing, now we have to select a model that we have to run to choose. So here we have selected a logistic regression with a random state 16. Now here I have fitted the model on training, and after the prediction is done, model evaluation. For model evaluation, the best matrix that we have to use nowadays is confusion matrix. Basically, confusion matrix is a 2 by 2 cross matrix. If you are using a binary cross classification, basically, so in binary classification there are some true positive, true negative, false positive, false positive, negative is there. So basically it is used to visualize. Here is the true positive and true negative. You see that out of 115, 39 and 30 and 8 are, these are the wrong prediction that our model done. And out of, so we can say there is approximately 80% higher accuracy. So this will be a good model, we can say that. But we have to know how, like sometimes if you are using a diabetes prediction, then you have to always, so nobody, the model is working fine or not, because here true, like false positive and false negative are there. So false positive rate is high in that case, but so we have to check that manually. And this is the heat map, and these are the values that our model predicted on 30. So we have to check that is model working fine or not. without diabetes, and these are the some advantage disadvantage conclusions. Now coming to the most important question that may be asked in interview, like, so these questions are prepared basically on the basis of logistic regression only. On top of the logistic regression, this question may be asked like, what are the data challenges during model development in logistic regression? So what basically, what are the challenges do you have, we have to face during model building, model development in logistic regression? So basically, the first challenge we have to face of the data missing values. If the missing values in your data set, then we have to do like feature engineering, feature like exploit data analysis. Basically, this will take some time. So that's the problem. Mm, like the first challenge that we have to face, and the second is a mixed measurement scale. Like, okay, so no, what happened, the second challenge that we have to face it, uh, basically, suppose there be recently see our data set, there have a column some like diabetes or like pregnancy, something like and cholesterol, something, some columns are there. But you have seen that some value are ranging from 0 to 5 and some values are ranging from 1 to 100. So this will be create a problem because this will not coming in a right manner. So firstly, the model will take a huge time to, like, suppose if there are a column that will contain a values from lakhs, 0 to lakhs and maximum like something, then you have to do a very high computational at the time of model building and training. So, and the accuracy is also not good if you are using this value because the scales are not at that level. And so, what we have to do, we have to normalize this value. There are some techniques that you have to follow, like there is a minimax skill are there, and normalization is also there, like and some standardization. Like in normalization, we have to normalize this value by dividing the max value, and some min max scalar is also there. Here we have to divide change the value into minimum to like -1 to 1, and some and like expo like standard normalization is also there. So in the standard normalization, we have to like create like mean is 0 and standard deviation would be 1 in that case of x in exponential distribution. So that we have to do manually all of these challenges we have to face, because if you not do a normalization to your data set, then the accuracy is also not good, and to do like very hard work, like very hard work means ki at the time of at the time of training you have to, it will take much time. Basically high dimensional, you have a high dimensional data set, this is the challenge. Like, so you have to do a apply a dimensional reduction theorem here. So by applying a dimensional reduction theorem, there are some algorithms that you have to apply, something like for dimensional reduction we can use hmm, what we have used, there's some algorithms that we have to apply, like box Cox transformation is there, and some algorithms are there to, like if your dimension, if your data has higher dimension, so what happens, some find a correlation. Firstly you have to find a correlation in your data set. If there is a columns which contain higher 80 or 90% of correlation, then you have to remove that column, because these are not the right way to do a problem. If you have a like correlation between many columns, so you have to apply a multi-collinearity theorems on your data set. And rear target event, like imbalanced data set means in your data set, suppose you have 100 data points to train a model, and if you have a 90 points in your one class and 10 points on the other class, then this data set we can say is an imbalanced data set. Suppose that also anomaly detection data set is mainly a imbalanced data set, because suppose you have a problems of finding a note is a like fake or real. So in that case, if you have all 90% of the real notes and 10% of the fake notes. So basically, this is a embellished data set problems like anomaly detection and many problems are also there. So this is the some challenges that we have to face at the time of training the logistic regression model. So now again, so what are the challenges that we have to face at the time of logistic regression? Like if your data has a missing value, then we have to do EDA feature engineering at the time. And the second problem that we have to face, like multi-collinearity, means कि if your data set has a many problem like columns in your data set, then we have to do a multi-collinearity theorem. Have to apply. The third challenge we have to face is that कि the data set will not contain like mixed measurement scale, means ki the data set has different types of ranging values basically. So we have to see that also, and the real tiger like embellished data set. Then we have these are the challenges that we have to face at the time of applying the logistics, and we can get this type of data also. What are the analytic challenge during model development? Analytics means same as the like missing values, non-linearity, model selection, select the most accurate model, but it may be an overfit. Means that if you are using if you want to use a model, sometimes it will be overfitted. Then you have to apply some algorithms like what we say that like parameter not parameter like fine tuning. We have to they have to apply fine tuning after if you get a overfitting model. Non-linearity relations between x and y is non-linear, hence difficult to model. Okay, this is also a challenge of analytical challenge during model. Suppose you get a problem that will can't that will not have a relationship between x and y. Mm, like this is a deep mm, mm, relation between x and y, then you can't use this type of model. Then you have to go to apply a deep learning model like ANN, RNN, and CNN. This will be able to solve your problem only if you have a non-linear data set. What are the difference between linear regression and logistic regression? So basically this question we have already done before at the starting of this video. Like in linear regression we have a linear relationship between data set, and logistic regression we have a classification problem basically. So firstly we apply a linear regression on top of in logistic regression. Firstly we apply a linear regression on top of a sigmoid function. So after applying a linear function, we apply our sigmoid function on top of the uh, sigmoid function. So this will convert your value into 0 to 1, so that we can get a like class that we are want to predict. Mm, so this is the like differences. Linear regression conditional means of response is between infinite and infinite. Logistic regression conditional means response is between 0 and 1. Okay, so basically linear regression the value will be ranges from minus infinity to plus infinity. In logistic regression the conditional mean will be response is between 0 to 1. Relationship linear regression relations between independent and dependent variable, or logistic regression independent and logs of dependent variables basically. Normal random error, and to find the logistic regression error does not have a random normal error, binomial error is there. Okay, so what is step by selection method? Forward, backward, step by what are the assumptions of linear regression? Okay, so what are the assumptions of linear regression? The first assumption that we have to apply that our model like data is linear. The first assumption that we have to follow before applying a linear regression. The second assumption that we have to see that our data set is normally distributed. Is the, the first is linearity is there in our data set. The second is our data set is normally distributed with a mean of zero. We can say that error has equal variance. This is fine. Error are independent. Okay, that we have to like assumptions. And the other assumption we can say that in linear regression, other assumptions I don't remember exact. How do you penalize the model for extra variables? Well, each matrix is a different penalty of additional value tries to minimize your losses. What is the method of maximum likelihood? What does odd ratio signify? How do you decide the cutoff for the output of logistic regression? Key matrices. Key matrices used to check the performance of logic. The first matrix that you have to apply is the like confusion matrix is there, accuracy matrix is there, error sensitivity, specificity, ACROC curve is there. How do you handle missing values? Okay, so for missing values, we have some techniques to handle the missing values. If you have a regression problem like continuous variable, then you can fill it by mean. And if you have a categorical values, something like that, then mm, you have to apply some like you can apply with mean, median, and mode. But if you have continuous value, then the best way to fill by mean. And if you have a classification problem, then you can fill it by the maximum number of times that we are can, or we can say that the mode of that value. Impute with the mean or median and create a missing value indicator. If you have categorical value, then impute with a new label. Regression. Okay, so they are saying that if you have a categorical value, then you can impute with a new variable, new label you can assign, or you can fill it by the mode of that value. Regression implementation does not involve target variable and can be used when two or more variables are highly correlated. However, it will fitting increase computational time and increase scoring effort. Also, clustering. It is condition of other variable. The cluster mean is used to replace the missing data point. In cluster, basically, in clustering algorithms, if you are applying, then you have to fill it by mean also. But in multicollinearity, so basically in multicollinearity is there when if you have a problem, suppose that will contain a 50 columns, then suppose 30 column have a highly correlated. Suppose that there is a correlation between greater than 90% in 30 column, then this multicollinearity will come in the picture. So you have to remove all the correlated columns. So it will convert. It will take only the best columns that will have in your data set. Between two variable multicollinearity is the relationship between two or more variance influence factor. Basically, how do you remove